talk, and now we are going to shift focus to the panel discussion. So thank you again.
Hi. Nice meeting you all.
Thanks, Dee. Awesome. Let me just transition.
Hello.
Great. Okay, I think we're all here.
Yep.
Great. So for our next section, we are going to be transitioning to a panel discussion. So I'd like to give a warm welcome to our panelists for the panel on applications of continual learning. So let me give a little context before we start to hear from these amazing people who have kindly joined us today. The motivation is, as discussed many times today, while the concepts of continual learning and catastrophic forgetting are extensively explored within the academic community, which many of us have been very involved with all these papers the past 6-7 years especially. Today we're aiming to delve more into their relevance and impact on a real-world application. So where is continual learning practical in the real world outside of papers and academics? How do large-scale models perhaps change the directions of continual research, or do they at all? So the panelists we have today have a combination of very, very rich academia backgrounds and industry experiences, some of them having both pieces of that pie. So I'm certain we're going to have a very, very great unified perspective to all of these questions we asked today. So I have a few questions in mind, but audience participation is strongly encouraged. So after the intro question I'll ask in a minute, if you in the audience want to post in the question answer or post in the chat, then we'll try and get your questions involved to the panelists as well. Please, if it's a general question versus a targeted question for a specific panelist, please indicate that in your question. So formally introducing our panelists, we have Dr. Sayna Ebrahimi from Google Cloud AI Research, Dr. Camila Gonzalez from Stanford, Dr. Christopher Kanan from the University of Rochester, also formerly at Page AI, Dr. Zsolt from the Georgia Institute of Technology, and finally Dr. Bing Liu from the University of Illinois, Chicago. So I'm first going to ask everybody an introductory question. We'll go down the line, and everybody could please just briefly introduce yourself a little bit more beyond the name and title I just announced for you. And as a little extra, give just a quick perspective on what you think continual AI's significance is in today's landscape. That can be, application, academic, whatever you think. Just a brief background on that. We'll start with you, Dr. Liu, if you'd like to start us off. Sorry, I think I clicked on asset.
Okay, this is Bing Liu, and my background was data mining, and later on I got into web mining, and then that led me to this sentiment analysis. So I did lots of years of sentiment analysis in natural language processing. And then I did 2 startups, although not successful. I mean, my students was reasonably successful. But with the startup, I realized so lots of continual learning problems, because when you analyze sort of reviews or opinions about all the products, they have lots of similarities. So at that time we got sort of customers, the clients which give us, today give us another for sort of product, let's say cars, to do analysis. Next day some drugs. The day after that is something else, the bicycles or lots of stuff. And then obviously this is the continual learning problem, because you can always borrow knowledge from the previous task to help you do better in the future. So you don't want to sort of everything you want to learn in isolation, because the amount of data you accumulate for that particular product may not be enough. But a lot of things in the past will help you to do that. So after I finished my startup, and then I thought about this problem, and then that's why I got interested in this lifelong learning. At that time, it was called lifelong learning, and then continual learning. And then now I basically mostly focus on purely sort of machine learning aspect, not in application. But I did have some application experience also in natural language processing, because when you have natural language processing, you have, for example, in dialogue systems, and you always learn new skills. For example, you have a system which can report sort of weather, can booking hotels, sort of things. But next day I want to add some other new skills. So you have intent classification. Oh, that's essentially a class incremental learning problem. That's a real problem. And we worked with one company before, and we couldn't solve the forgetting problem. So it was not practically used. And but that was very important. The company was interested in that because so they want to add themselves, but their clients also want to add themselves because they don't want to wait until sort of sometime then they go to this software house to add that domain. So they want to add themselves. So this is essentially a continual learning problem, but was very difficult to solve. I think let me stop here. Yes.
Thank you. That's a great introduction, and I'll just go down the line alphabetically by first name. So Dr. Gonzalez.
Yes, thank you very much, James, for that great introduction. Very happy to be here. I believe I am the most junior person, so very proud to be with these amazing panelists. So I did my PhD on continual learning for medical imaging applications. I mainly work with chest CTs and MRIs. And I would say the focus during a big part of my PhD was more on the privacy aspect. So what happens when we lose access to previous samples as time goes on, which is a very realistic scenario because often you are able to use some scans, some images to train your model, but cannot really keep this in a central location. So that's what I was always the most interested in. Now in my postdoc at Stanford, I work a lot with neuroimaging data, and it's a very similar situation. You can even imagine as a user, you may be willing to let somebody use a structural or functional MRI scan to train a model, but you don't really want that data to be there for anybody to use. So I have been especially interested in methods that don't need this information, that allow us to preserve previous knowledge without needing to preserve this data, which would break significant privacy constraints. Yes.
Thank you. And then Dr. Kanan.
Hi, everybody. Great to be here again.
Again, yes.
But yeah, so I'm Chris, and I've been working in continual learning a lot, but it's like a primary focus in my lab for about 7 years. But I got really interested in it during graduate school, actually. So I was kind of contrarian and working in deep learning before it was hot. And I read there wasn't much out there, right? It's not like today where you have this fire hose. I had to go back to old stuff, right? To read papers. And I saw the what for us famous McCloskey and Cohen paper, and that got me really excited about that problem. And I didn't really have a chance to pursue it until I was a professor and kind of had a student saying, "I'm bored with what I've just done. Give me another problem." I'm like, do this thing I've been wanting to do for a long time. So that's kind of how it got started. But really, what really got me interested in it, well, this might sound provocative, but I've often picked problems in thinking what would be necessary for artificial general intelligence, right? And I think, and what's kind of unsolved, right? Not trying to do it, but just thinking what's a prerequisite thing you would need. And continual learning is one of them, right? You would need that capability. So that's like what led me to be interested in it. And starting to think about it. However, as I've kind of like matured in this space, I do think there are a lot of real world applications where it could be really useful, but I feel like most of the way the academics are designing their experiments, designing their algorithms is not aimed at those specific use cases. And specifically, two of the most kind of prominent ones, in my opinion, are more efficiently updating models rather than periodically retraining, which is very common in industry. And the second one is on-device learning, which is being used based on conversations with people at some AR, VR places for those devices to do continual learning on them. But they never pulled papers. I don't know precisely what they're doing. I actually bought an Oculus Headset to try to sort this out. I did work as the head of AI at a medical AI company for a while, for 3 years. And one of the things that came to light there was the challenges in trying to use continual learning for this kind of work. We talked about it occasionally just because I know a lot about it. But just there's a lot of regulatory hurdles for doing anything about that, right? You have to maintain provenance of your data. You have all this kind of other things. I do think it could be useful for getting like annotations and things like that in an iterative way. Yeah, I'm very much pro in terms of the applications. It's just a matter of having the community align their work with said applications.
Outstanding. Thank you. Dr. Ebrahimi.
Hello, everyone. Hi, this is Sayna. Thanks for the nice introduction. Happy to be here and happy to be meeting you all. So I did my PhD on, I was at UC Berkeley during my PhD, and I did work on continual learning and test time adaptation a lot. And then when I joined Google as a research scientist, I thought that was why I was hired here. But turned out continual learning wasn't that much of a concern. For the specific reasons that Chris also beautifully mentioned in his talk, that's exactly true. The assumptions that we cared a lot and we made, like when I was working on continual learning in the community, weren't aligned with what was being done in industry. At least I can only speak for the team that I am working with, this particular part of Google, and I'm not representing the whole company. Obviously. So yeah, a catastrophic forgetting in the sense that all the limitations that we were making instead of, in terms of assuming a specific amount of memory, replay buffer, all that, they don't exist. Big scale companies don't care about those limitations that much. And then there was this emerge of all the LLMs and foundation models, and things drastically changed. And yeah, I mean, I can speak more to that, but I want to get into the questions. But things are different than I thought.
You're going to provide an outstanding perspective here. And then finally, last, Dr. Kira.
Sure. I'm Zsolt Kira. My background started at the intersection of machine learning and robotics. And so if you look at robotics, a lot of kind of the AGI-ish or kind of higher level kind of machine learning AI limitations exist as well. So clearly one of the fundamental differences between the robotics and other domains is, you kind of train your models and then throw it on a robot, and inevitably they'll see lots and lots of different distributions of data. So my lab has looked at a range of problems, including self and semi-supervised learning, because robots have nice access to lots of unlabeled data for free, essentially, as they explore the world, out of distribution detection, concept discovery, and of course, continual learning. And I agree kind of with everyone here. I think one of the things that we've been looking at in continual learning is, for example, more kind of realistic or real world task distributions, moving beyond kind of replay and again, leveraging lots of unlabeled data or data generation. And as mentioned, the times have changed. So really a lot of these foundation models have, really changed the game, both in terms of kind of solving a lot of classical continual learning problems, but introducing a lot of really interesting open research challenges on how to update these large models. So, while I agree kind of a lot of the assumptions that we started with in the community don't really exist, maybe it may not have existed in many domains, but certainly not now. Clearly, there is something still kind of wrong with how we train our models. I collaborate a lot with industry, and they have hundreds of models in their company, and really PhDs that babysit those models and decide when and where to retrain them. And so, I think there's a lot of open questions that can be really practical if we just approach it the right way.
Great. That was a great introduction from everybody, and I'm going to ask a question that was very, very related to what almost everybody just said. Let's dig a little deeper. As we had some comments that maybe, I think most of us agree here that maybe the catastrophic continual learning problem that we write for our CVPR papers may not directly translate out into the real world. But let's get a little more detailed of, how do you think specifically the problem of catastrophic forgetting in academic settings differs from real world settings? Specifically, you could either talk generally about how catastrophic forgetting has some incongruities between academic and real world, or you could give a specific description of catastrophic forgetting problem that you have found in your industry experience or industry collaboration experiences. So I'll kind of popcorn this. Maybe raise your hand if you would like to speak, and then we can go from there. Yeah, okay. Camila, there you go.
Thank you. So I think the biggest difference is that in academia, when we are talking about continual learning or catastrophic forgetting, we typically already know beforehand which sort of shifts we're going to have in the data. We know that we're going to have catastrophic forgetting. We have measured this, etc. And then, of course, in the real world, you don't know what shifts are going to happen. So how you prepare for this is completely different, I think. And for instance, just one example, I mean, many examples, especially in the medical domain, of changes that you have in the distribution of data that you were not anticipating, and you find in your model, and it starts to completely fail. So then you start having all of these different states. So I see this all the time. So that's the largest difference. That in the academic setting, we always know what's going to happen.
Is it task incremental? Is it class incremental? Is it domain incremental? Do the class sets change? Yes. Joel, I think you had your hand raised next, so we'll go to you, Dr. Kira, and then Dr. Kanan.
Sure. Yeah, I totally agree. The distribution, and again, like real world distributions sometimes don't even have catastrophic forgetting, because you actually in real world do see things that have occurred in the past. And so, yeah, I mean, I think the kind of actual types of distributions that we study is important. The other thing is, I guess it's just the underlying, like really just where we start from, like the premise of the problem itself. So, in industry, the upper bound that is just training on all the data is like what they do. And right now it's doable in the sense that it takes lots of compute. Maybe, it has negative side effects for like, the climate, but it is what they do. And so really what you're trying to do is compete with that upper bound, not try to get closer to it, or you're trying to start from that and really reduce other dimensions, such as things like computation, efficiency, and things like that. And so, I think kind of, and labeling is okay, but unlabeled data is vast. And so I think there's just, the underlying actual like premise of the problem itself is very different in industry. And I think that's kind of, it's important to to try to like look at what are those assumptions, start from those premises that are realistic, and then tackle the problems. Even sometimes it may not be as, sexy, like it may not, involve things like architectures or loss functions or other things. Maybe it's just, data curation or other types of things that, are involved that maybe aren't as publishable, but can push the boundary on practical continual learning.
Good points. Great. Thank you, Dr. Kanan.
So I absolutely agree with Camila and Zsolt there. Too many algorithms are designed to be kind of, for the test rather than be a general algorithm that is robust across distributions. And you never know in industry what you're going to see. So you should test all these distributions. And to Zolt's point, if we don't at least have the system that works at least as well as the offline model, and either maybe exceeds it, but at least is cheaper to train, nobody cares, right? So, I mean, catastrophic forgetting does matter, because if we don't, basically, I don't want to call it catastrophic. It's not even catastrophic anymore, right? But if you forget it all, you're not going to get. It's not going to probably be good enough. So for a product for somebody to be wanting to use it. So I absolutely agree with both of those points. But I do think that in the light of everybody using these foundation models for things, and people are fine tuning them, they will catastrophically forget. And they're just one-off, and we don't even know the provenance of the old data, right? The only technique we have in our toolbox that really works well for adversarial distributions, and like I said, you don't know what you're gonna get. Maybe you probably won't get incremental class learning, but what if you did? Is rehearsal or replay, and if you download a baby foundation model, right? It's all we can get, right? We well, except for our colleagues at Google here. But if you get one of those and you want to fine tune it, as Google showed in their PalmE paper, if you don't do any mitigation, it's going to catastrophically forget. it's going to lose a lot of the original performance capabilities in terms of something like natural language generation. And stuff like rehearsal probably won't scale to that kind of a domain. And with the rise of foundation models everywhere, it may be tricky to catch these things, but I think it could be relevant.
Thank you. And I guess, yeah, Dr. Ebrahimi.
Yeah, sure. So I definitely agree with what everyone mentioned. Those were great points. So I just want to add to those. One thing is that what I have seen is treating past data just like new data. That happens more often than really caring about this data has been seen by this model before, and we absolutely want to retain the performance. It rarely happens that way, at least in industry that I've worked with. So they treat every data point that you want your model to perform good at as a new data point, and they choose adaptation rather than avoiding catastrophic forgetting. That's one point. And also, if you think about it from the basically computational aspect, it's also believed that building a model that already has great zero-shot performance and then adapting from there is more affordable than thinking about how to avoid catastrophic forgetting for all different kinds of applications that happen in industry. That's also another perspective that exists. And also for the situations that we can think that catastrophic forgetting matters to them, the situation is far more complex than class incremental learning or forgetting a specific class or the way we used to treat it in continual learning. It's more about more complex tasks of reasoning. Hallucination, you can think of it as some sort of forgetting because you never know if this data was seen before during training this foundation model or not. And in conversational AI, where it happens that you're interacting with a model and you don't want the model to forget your initial question from the beginning of your chat, right? That's also another way of looking at catastrophic forgetting the way it is being looked at now, which is very different than what I used to think of it. And also one more thing is that some situations they do want forgetting happens. So there is like kind of weird thing of privacy and that sort of thing that interleave with continual learning. For example, at a company like Google, when there is a model that has been trained on a lot of data, and for some reason the user chooses to remove their data. So Google has this commitment of removing that data from the model, and they absolutely have to do it legally. So right now, there's no choice but to go back and retrain the model because that data point has to be removed completely. So it cannot be reverse engineered and cannot be retrieved by any means. It's a good question from for continual learning community, how to think of intentionally forgetting something. How can we guarantee that? It's against what's being done, I know, but it's also a good question to think about.
And Dr. Liu, did you want to ask anything? Yeah.
Basically, I just when I did the introduction, I mentioned two real applications I sort of personally involved. So for the sentiment classification, that was a domain incremental learning, because the sentiment at that time would basically classify positive, negative, and neutral. So for every task, whether you are doing a car review or doing sort of medicine or whatever, there are all these three classes. So that domain incremental learning. And this domain is field is very interesting. Is the forgetting is not the major issue, because a lot of these domains, we call it domains, or we call them products or services, they are very similar. And so in that sense, it's more of knowledge transfer. So in practice, you definitely got lots of knowledge transfer. But it does have forgetting when you deal with something really different. For example, your system probably learned lots of stuff from the electronic products. So now I give you a beer review, the beer was really terrible. Now the results completely useless. What you learned before is completely useless. If you learn this beer review, sometimes when we talk to some guys, even normal people cannot understand it. So people say those guys are got drunk, and then they write these reviews. And so that definitely is an issue. We did try the beer, and then it's very bad. But if you are doing similar type of thing, they do very well. They sort of help each other. Then there might be some sort of forgetting, but knowledge transfer is dominating. So another application which I also personally involved was just to mention that dialogue systems. So you want to add more skills. So the company I work with was they have two applications. One is internally, so they want to add something, add new skills to that sort of to the model, which means you need to add more intent classification tasks. For example, you have this booking a hotel, you have a few attentions. So this is the class incremental learning. So in this case, and they can have they can have the past data, whether it's sort of a small buffer, big buffer is not a big deal. So as long as they can do efficiently, it'll be fine. But they also have clients. The clients, they want to sort of add this to the model as well. So in that case, these clients, they don't see the data of this company's data. So they can only use their own data to add into their model. So that will be a problem. So you can't really see, you can't have buffers, you cannot see the past data, you have to use your own data. So these companies, these clients, they come up with something they want to add quickly into that dialogue system so that they can be used by the user sort of very quickly instead of waiting for many months to get the people who sell that product, sell that software license from that licensed software and ask them to include. That takes too long. So they want to be able to do themselves, but that's caused a problem. And in this case, in both cases, and the forgetting is an issue. Forgetting is an issue. But they do have something sort of, they call the sort of engineering solution, try to deal with some forgetting. What they do is very simple in a sense. So the objective is forgetting in that case is say, for example, you say something this morning, but if I say the same, if I ask this system the same thing in the afternoon, and you should not give me different answers. If the first answer was correct, so in the afternoon, no matter what you change, you should not give me a different answer. So because you want the system to be predictable. So let's say in the morning you ask to do something, and in the noon, and then you sort of improve the system a little bit, sort of get the system to learn something more. And in the afternoon, the guy ask the same question. So you may have some forgetting, but you must remember that question and the answer. So in this case, they can do an engineering solution in the sense they could remember what this guy has asked in the morning. So even you have some forgetting, so it's not a problem because they remember the question, they remember the answer. So that even you give it the wrong answer, they will correct it. Okay, so they do it this way. Which is quite interesting. So that forgetting will not be a big issue, but they cannot do this for too long. So basically means that after some time they still have to retrain, in a sense. Right.
That makes a lot of sense. Yeah, we have a very broad perspective and views, so this has been great. So we have a lot of questions now in the question and answer, and I'm going to try and combine some or deprioritize ones that have sort of been asked. But one question that overlaps is talking about, and we kind of gently touched on this earlier, but I think people would like to hear more about it. Can we talk about how maybe industry's perspective on continual learning may have changed since the introduction of large-scale LLMs and other types of models? Another way to ask that is, do you think foundation models alleviate, intensify, or shift catastrophic forgetting types of challenges that we may see out in the real world? So same as last time. Oh, Dr. Kanan, there we go.
So I'll just say what my take is in terms of what I'm hearing and what I think. So what I'm hearing is there's a lot of people who think maybe we don't need continual learning because these models know everything, right? So do you really need continual learning further? I don't agree with that. Where I think we need to, like they literally can't be, they're like locked in time, right? It'd be nice to be able to update them without training from scratch and provide new knowledge. And what if I want to personalize it with my own stuff, right? So I definitely think there's a role to play for continual learning here. And I alluded to this earlier, but I do want to make this one comment. because I've been trying to do these things and get papers like this published. And I continually hear from reviewers who do not like what I did, saying, I fundamentally believe continual learning is about starting from scratch. And if you start from a big model and try to improve it, you're breaking the rules. That's not my continual learning. And I'm like, well, I don't know who made you the arbiter of what this is, anonymous reviewer, but I think there's a lot of applications here and a lot of benefits if we can address these things. But we as a community are going to like block ourselves from doing this. At least in my experience, this happened twice. Yeah, I'll stop there.
I mean, I think now if you do continual learning without using pre-trained model or large language model, you shouldn't be doing it because they obviously helps you a lot. And in terms of forgetting and in terms of performance, I mean, if you still train from scratch and then train without any pre-trained model, I don't think it's really helpful. I mean, in terms of continual learning, Chris just said about this, when you have large language models and you don't need to do continual learning anymore. I agree that's not true because the continual learning themselves need to be continual learning too, right? And that's a big deal because at least, I mean, I heard my students, they were doing this kind of stuff in companies. They have two kind of situation. One kind of situation is this pre-trained model need to be sort of update periodically. The second thing is they have a new skill, sort of a new domain, sort of was a more specialized domain. They want to add it into this thing. And in both cases, they have forgetting. And what they are using now, I don't know whether I can tell you, I can say or not, but what they're using now, they did not tell me what the technique is, but they tell me something. So I think they are using knowledge distillation. I believe, but they did not say this term, not term for me, but they explained they were doing something, and then that's my guess. And they said without that was not good. You have lots of forgetting. But I don't take my word because I don't really know exactly what technique they're using, but they are using. Yeah.
Yeah, I think from my perspective, yeah, sorry to cut you off, but I think the premise of the question is interesting because it says, how has industry's conception of continual learning changed with these foundation models? I think it's the opposite, which is, industry wasn't as interested in practically using continual learning because they were already using even pre-foundation models, pre-trained models, right? So I think if anything, this shifts academia like two more useful directions, where if we do use these large pre-trained models, that is what happens in industry. So I think that's actually a good thing. I think in terms of whether it shifts the problem or changes it or whatever, I mean, I do think there's a significant shift. That I think, Sayna mentioned the good point, which is like what forgetting means is different now. Like it could be hallucinations, but it could be other things like, now that we're dealing with generalist models like ChatGPT or whatever language models, what does forgetting even mean is kind of a hard thing because it's not just a class or a label. One interesting kind of perspective that I haven't seen a lot of is a lot of these models use retrieval and external knowledge and all these kinds of things. And so there's a question of kind of like which of those, should I like remember or not as we're discovering new knowledge. So there's some cool work, for example, in robotics where an agent is walking around and is actually discovering like programs, like we're generating programs using language models. And so there's a question of like, which programs should I keep or not keep depending on the task distributions that the robot has to do, right? So all of these questions are really changing what the meaning of forgetting and the whole problem space is, which again is a good thing. And I think it's exciting because there's lots of open research questions.
I think that's me. Yeah, those are great points. I totally agree with Zsolt. It's definitely a good question to ask. What is forgetting? And my perspective on what's being done here is that it's more approached as a combination of problems, not just continual learning and not just caring about catastrophic forgetting. Everything is is being done based on its priority and based on its importance and based on what's at stake. So it's a combination of continual adaptation. If forgetting is a strategic thing to do, then to avoid, then it will be done, and it has to be done in a very specific manner that is guaranteed, and you can, bet your money on it. So that's I think the difference. For example, when these like privacy challenges are at stake, you cannot take like a method that has some level of forgetting for a specific application, because you need to be certain about how much it does not forget. So it's basically mostly adaptation. I think I'm answering some of the questions that I can see. What are the biggest challenges? Those are the challenges. Basically, how to continually adapt. It never ends. It's a truly online stream of data, and with all the hidden things that, like, I don't even know what Google models are being trained on while I work out here. So no one knows what exactly this model has seen, whether this encountering example is like bad performance on this particular example is called forgetting because the model has seen it before. You never know. The only thing you can do is to quickly adapt. So online devices, like on-device quick adaptation, that's a big concern. And then forgetting should be avoided to whatever importance level it has to the company.
Yeah, one point that I want to kind of accentuate, which was alluded by your point, which is I think safety is not really like thought about in continual learning, but in reality, no company is gonna like take a model and just let it rip on random data and deploy it, right? I think you need guarantees and some ability to bound its performance, if nothing else, just through like regression testing on bias and safety and performance and things like that. So there's probably interesting research questions there that I don't think a lot of the continual learning community has really looked at.
That is a very great point. Like when safety is at place, then they tend to incorporate any tool at their disposal to do retrieval augmentation, to do like fact checking, to do anything that you can to avoid outputting something that is outrageous. So whether it's called good performance or avoiding catastrophic forgetting, it has to happen by using any tool. So it's like a combination. It has to be personalized solution to the user. Sometimes it deals with safety, deals with confidentiality. It's a combination. It's not just avoiding catastrophic forgetting.
Go ahead, Camila.
Yeah, so I have a small comment related to this safety issue. I think one thing which is maybe a little bit worrying is that for a lot of systems in many different so for many use cases, when we perform this evaluation where we try to provide these safety guarantees, we are actually doing this in static data. So we typically do this before a product or system is approved, and then we expect this to continue learning. So there's a bit of a problem there where we also need to shift on having quality assurance systems that continue providing these guarantees as the model goes on, which I don't think we have in a lot of domains.
Okay, so I want to change the subject a little bit. There is a question at the bottom that I think I know two people on this panel who might have very different opinions on it, so I want to ask it. So bottom question is talking about memory constraints and whether or not you think memory constraints are ill-defined in theory and not applicable in industry. So the suggestion is should we maybe even discuss removing in this memory constraints and just focusing on computational efficiency, or can you think of places where it's super necessary versus not necessary at all? And I know Dr. Kanan was going to speak first, so you have the floor there.
I mean, okay, for most industrial applications, pretty much all of them, it's not going to matter. It's going to be about the efficiency in terms of learning and offering some benefit in terms of doing, you have to hit the baseline of being just as good as an offline model, and you get there more efficiently, right? It's got to be something like that. Otherwise, nobody cares about your memory constraints or your toy data sets, and you're like, I'm going to restrict it to 10,000 images. Why 10,000? Well, who cares about this? But I do think it matters, just not if you were thinking about on-device learning. But oftentimes people just like throw out random numbers, or like, I'm doing it to have no, well, it's very hard to get a paper. I've tried with no memory constraints, except it, like, you'll get roadblocked. Like, this is another thing I've been trying to do. I have a couple papers like this. I now have complementary experiments with memory balance, even though I don't think that is useful, but I did it anyways to placate people. But if you are interested in this problem, I think you should really aim your paper at thinking about what would continual learning look like on a very memory constrained device, which would be a mobile phone, for example, or like a small embedded network. In that case, you're going to need additional criteria. Probably going to need low shot learning, or you might think about semi-supervised learning, right? Because you're not going to have users just labeling 1,000 images for you and wanting it to work well. So, but we don't really aim our research at these specific questions. It's just kind of like, I'm better at C/10 than you with all these changes I made for some reason. So I think memory does matter, but we need to think about the applications. It doesn't matter for most of them.
Except for Dr. Gonzalez.
Yes, so I would say, at least when it comes to medical imaging problems, I would say persistent memory is never an issue. You always have enough persistent memory. Data is very, very expensive to acquire. If you have this, you'll definitely get some persistent storage for this. When we're talking about GPU memory, I have tried many methods for continual learning that have shown great performance on low resolution images, that then when you apply this with quite large 3D scans, they just cannot. I mean, you need like so much memory for this to be able to run that you just cannot really apply them. So in this respect, I think actually GPU memory is quite a limitation and something that we should focus on. And then I think it's always a bit of a trade-off on basically maybe a bit more related on the time that it takes for doing a certain amount of retraining. If it takes very long, then depending on your specific situation, it may not be feasible to do this. Yeah, so this is, it depends what sort of memory you're looking at, and depends on the scenario and the type of data, definitely. And so one thing that I never, that I tend to not go to techniques that try to like optimize the memory buffer of like persistent memory, because I don't think for me that's a constraint. I always have persistent memory.
Yeah,
Is data privacy?
Thinking about, like buffers for rehearsal and things like that. Those kind of memory. But I think your point is well taken. There's so many algorithms people design where they don't scale at all, and they didn't think about anything real. And trying to run them, you can't even run them, right? You can't even run them on like real data. And I think we should. To me, it's not acceptable.
Exactly. I find especially many distillation-based methods that I really like the concept of them. I have difficulty applying to larger images.
Yeah,
Is
in many
data
cases, I
privacy?
think
Oh, sorry.
So I just want to have one data point is again in the sentiment analysis, we do have some companies previously, they don't want the data to be used by anybody else. And they said that you can sample a few. For example, one of the cell phone company, they give us the data, but they said you can train a model fine, but you can't let this data to be used by anybody else, other clients or something. No, you cannot. Yeah.
I want to transition to one last question before we do final thoughts and wrapping. This is one that was just asked. And I thought it was a good one, and it's talking about what are your thoughts on plasticity? We keep talking about catastrophic forgetting, rightfully so. But on the other hand, how does intentional forgetting or retaining plasticity and making sure that we can continue to learn, the forward transfer part, how does that play into maybe large-scale continual learning problems today. Go ahead, Dr. Gonzalez.
Thank you. Don't want to monopolize this anymore. So I think what I feel at least is, of course, plasticity is very, very important to maintain. But one very good thing about plasticity compared to rigidity or backwards transferability is that plasticity we can always measure, right? We always know when we don't have plasticity. So this gives us a lot more possibilities of thinking about how to address this, even in a real setting. If our model is not learning, we know that it's not learning.
I mean, my experience, if you learn a lot of tasks already, and then you're learning the next task, it should not be a problem. And pretty much in my sentiment analysis research, and also not research in that practical kind of application, and also in the image type of thing in terms of research, if you learn a lot, and then later on, it should be fine. I think the main issue probably is because the feature you really learn, so you don't really have a problem of plasticity.
I don't fully understand the question. Like, plasticity is essential for continual learning, otherwise you can't learn anything more. So yeah, you have to have plasticity.
My guess was the capacity. You basically full. You can't learn anymore.
That's an interesting thought. I try to say on paper where I'm like, what if you make the network really narrow? What happens? Yeah.
We did an experiment. We did an experiment is if you, of course, you got to have your network sufficiently large. If you learn a lot, and you keep learning, you increase another double the thing. It's not a problem actually, not too much. But if you don't learn a lot, your network is small. Obviously, it's going to be a problem. Yes.
Great, so since we're getting actually technically over the time that I asked you to reserve, I'm just gonna go with a last final round and maybe in parallel answer some of these last remaining questions. So if you just had last closing thoughts from each of the panelists, and if you don't have a specific closing thought, maybe you could mention, we dropped many today, but if you have any specific applications of continual in industry, like a very particular one where you think, wow, you should be, you guys out here at this conference, there's this big problem that someone needs to solve, where the continual learning type of approach could be incredibly relevant. That could be something, or just a closing thought to sum up some of the open conversations that we've had today. So maybe this time I will go reverse order. So Dr. Kira.
Sure. So I mean, I've already kind of mentioned a lot of missing kind of research agendas like safety and all sorts of other things. I think maybe the closing thought is like, I think right now it's an exciting time. There's kind of a great reset happening in a lot of fields, and I would just encourage everyone to be open-minded as scientists to think about like what are the interesting and but also useful and realistic research problems, and not get kind of stuck in the old kind of way that we've done it. Like, Chris was mentioning, I think like at this point, fine tuning, large models is where it's at, right? If you just train from scratch and you do a bunch of awesome research, industry, like nobody does it anymore. We have these large models. It's kind of senseless to throw them away. Similarly, there's new opportunities for new questions, like question the premise of everything. I think given that now we're kind of, we can be reborn in some sense. So I encourage you all to, be creative and kind of curious scientists when doing research on this field.
Great. And then I guess, Dr. Ebrahimi, do you have final thoughts?
Yeah, totally agree with what Zsolt mentioned. Be open-minded. A lot of the research that has been done on continual learning has been done in the vision community. We have recently seen some in in natural language processing. They have been dealing with this problem just differently, but it's more in terms of like continual learning literature and terminology these days. But we shouldn't be just thinking about one or two modalities. It's always a combination of multimodal. I haven't seen that much continual learning in multimodal setting the way it's happening in real world, not just combination of two, image and language. That's one thing, and also be open to different scenarios of forgetting. Try to redefine forgetting, because just Zsolt mentioned the field has hit a great reset button. So a lot of these terminologies can be changed, can be adapted to the new setting. Rethink about what the model forgets. Was it intentional? Was it not? How can be avoided? And all that. Yeah. Thanks for reminding me.
Okay, thank you so much for being here. Dr. Kanan?
Well, I think there's still tons of exciting questions in continual learning, and catastrophic forgetting is probably not the one that I would place at the top of my list at this point in time. And I think it's an exciting time, but we have to kind of like align our work with real world applications at this point. You've seen other areas of AI, like take generative models, like they grew in terms of complexity and expectation dramatically. Whereas still learning, I feel like like take GANs, the first work on that was done on like 32 by 32 images, little images. Nowadays, you couldn't even publish something like that. Whereas in our community, we're kind of like stuck in a rut, like it's same things. In fact, you try something new and people will actually try to suppress you, which is reviewers. Everybody else is excited. But so there's like these real challenges, I think, with the community, and I don't know how to like move it forward. I mean, I've been talking about this for 2 years and things like that, and people always say, great, I totally agree. And it hasn't happened. And so I really think we need to move towards kind of specifying, why am I doing this at the top of your paper, and not just saying I'm going to do whatever the past person did. Like even the question, so I attacked earlier the issue of using big models and then continue learning that on them. I said don't attack that, brother. Don't attack that. That's good. We should be studying that. If you want to study something like starting from scratch, maybe you should think about that as a cognitive science problem, right? How do we do neurodevelopment? How do we do that, right? But so there is a reason to study that, perhaps, but you need to specify why are you doing that problem? The first continual learning papers, they always had to specify why they're doing it. Now, as we've kind of become popular, it's just, well, like, continual learning is something we do. I'm going to do whatever somebody else did, and now we'll throw in a trick. My results are 2% better. And so I think we need to mature.
I'm just gonna, what's the word, back you up there. Dr. Gonzalez?
Yeah, I completely agree with everything that was just said. Of course, we need to redefine what it means to forget in this current world of large models, and we will need to continue redefining what it means to learn and to forget. I think one point I would like to emphasize is that for actually using learning and continual learning in applications, we really need to sort of close the gap a little bit into the data sets and the schemes that we use for our papers and the ones that we encounter in the real world. I think that's a key component to not sort of adapt our data sets and settings so that our method works well in them, but to actually try to capture something a bit closer to reality. Yeah, thank you so much for the invitation, and thank you for the great questions.
Awesome.
Me the last? Okay.
Yes,
Yeah.
sir.
So I also agree with everybody's comments, and so I just want to add 2 points. The first thing is, obviously we are at the exciting time, and this continual learning, as I think about it, it's a necessary sort of technology or something for artificial intelligence, or artificial general intelligence, whatever that is. And another thing is, I think we need to look at the large scale. A large scale in the sense, if you think about language models, these things, and also even it's not language model, if not this big models, I mean, as humans, we normally don't learn a lot, right? We know a lot already before we can learn a little bit. So I think we probably want to change a little bit of I mean, not really change the shift the paradigm, but probably change the way we do it. And for example, we probably have to learn a lot. Then we keep learning a little bit. We keep going. In that way, instead of as we do now, we want every task of 5 classes. I mean, right from the beginning. That's not going to. I don't think that's going to fly. Yeah. Okay, that's it. Thank you very much for the invitation.
Well, thank you everybody so much. This was very, very insightful. I don't know, I guess I don't know if I can give a hands out on this type of Zoom, but yeah, thank you. We're gonna go to a quick break now. When we come back, we're gonna do a quick little reset with another reintroduction to the conference. So thank the speakers once more, and we're going on a break right now. Thank you.
This was great.
Thank you.
Watson.
Thank you.
Watson,
So beautiful. Yeah.
come
there
on,
you are.
come on.
Thank you, everyone. It was nice chatting with
Thank
all
you.
of you. Bye.
Bye-bye. Bye.
Thank you all.